The next part of chapter 3 now, we're going to look at percent composition. If you have a compound and you want to know what's in it, okay, this is what, like if you worked in industry, if maybe you work for the energy industry, they bring you samples of coal and you want to test them because really with your coal, the more carbon it has, the better. Okay, so you can run it through machines and the machines will analyze it and tell you what percent is coal. And if it's not high enough, then maybe you don't mine that coal. All right, here's an example of sodium carbonate. Okay, we know that 43.38% is sodium, 11.33% is carbon, and 45.29% is oxygen. Well, how the heck do we figure that out? Well, it's kind of like you figure out your grade. If I tell you you have 900, well, in order to figure out your grade, you need to know the total points. If you have 900 out of 900, awesome. If you have 900 out of, 3,400, not so great. So in order to figure it out, you have to know the total. Well, what you do for percent composition is you take the individual amount, the amount of sodium divided by the total. So you'd find the mass of this whole compound, and then you take each individual element and divide by the total. That's what percent composition is. Okay, so how do you calculate it? Again, I'm going to find the mass of sodium carbonate first, and then I'm going to divide each individual. And I think that's what this slide is. Okay, first determine the molar mass of sodium carbonate. All right, so I have 2 sodium, and again, I'd use 23. Carbon is 12, one of them, and then 3 oxygen. So I'd add those all together. So I'd find out when I add these together that the molar mass of sodium carbonate is 106. I wouldn't use 105.99. I'm not that anal, you guys, okay? So 106. Okay, now what I would do is I divide each individual. So I'd take like sodium here was 2 times 23 or 46. So I take 46 divided by 106. And here I take 12 divided by 106. And here I take 48 divided by 106. So you take each individual. See if you got that. Okay, so here's sodium. Okay, 2 times 23 again, or 46 divided by 106 would give me the percent. Now again, it's going to be a number less than 1. If it's not less than 1, you divided wrong. Okay, it'll end up being 0.4338. Well, percentage, you move the decimal over 2. So that's why it becomes 43.38%. And I do the same thing for carbon, 12 divided by 106. And then I do the same thing for oxygen. And when you add these numbers up, they should equal 100. If you get 99.9 or 100.1, that's not a big deal. But if you get like 98, yeah, messed up. Or if you get 104, yeah, messed up. So these percentages should equal real close to 100 because, it's just one compound. So again, if you're doing percent composition, you got to find the mass of the total of the compound, and then you just take each individual divided by the total. And make sure it's the mass. Like, don't just use 23 because there's sodium. There's 2 sodium. So 23 times 2 or 46 divided by 106. Okay, I hope I don't confuse you much, but you guys, I always round. I would use 12 and, 106. If you want to use exacts, go for it. But I like to round. Okay, so a compound is found to consist of 2.74 grams of iron and 5.24 grams of chlorine. What is the percent composition of the compound? Well, what I would do is I'd add these 2 up together. Okay, so what would that be? 7.98. And then just take this divided by 7.98 and this divided by 7.98. Okay, so again, calculate the mass of the product. Just take these 2 and add them together. So this is what your product weighs. Okay, 7.98. And then again, I take iron 2.74 divided by 7.98. And I take chlorine 5.24 divided by 7.98. Okay. So, and again, you'd get 0.343 and you move the decimal over 2 to make it 34.3%. And the same thing with chlorine. Sorry, I cut you off here again. I don't know where to put myself so I don't get in the way. But 65.7, again, 5.24 divided by. So when you add those 2 together, you get 100. So that, in this compound, whatever it is, 34.3% is iron. Well, if you need more iron than that, if this is some sort of iron ore, there's a lot of chlorine in there. And if you don't need chlorine, you probably want to look for a different type of iron ore. That's what they use percent composition for. Okay, so what percent of carbon in acetic acid. Again, the first thing I'd want to do is find the mass. Okay. So the mass of acetic acid, or actually 4 hydrogen, 2 carbon, and 1 oxygen is 60. That's what it weighs, the whole thing. Then I would take carbon, which is 24, divided by 60, and I get 0.4 or 40%. Okay, so that's how you do percent composition. You don't have to do every element if it doesn't want to. In this case, I was just looking for carbon. 40% of acetic acid is carbon, so that might be great. I might need more carbon than that. I don't know. Okay, we have 6 gram sample of calcium sulfide is found to contain 33.33 grams of calcium. Okay, so again, what would I do to find the amount of sulfur? Well, first I take 6 and I subtract 3.33 because whatever's left over has got to be sulfur because there's only calcium sulfur in my compound. So would that be 2.77? Is that right? 2.77. Okay, that's the grams of sulfur, and then I divide that by 6. It says I get 44.5. So 2.67. What did I do? 2.77. Sorry, you guys. I should use a calculator, right? 2.67. That's this minus this. Because if this is calcium, that's what sulfur's got to be. Divide by the total, and I get 0.445 or 44.5%. Okay? All right. Where are we at here? That's not very much. Okay, molecular formula versus empirical formula versus molecular formula. Okay, an empirical formula is the simplest formula. Okay, there can be multiples of that, and it comes in when you're looking at molecular compounds. That happens a lot. Like if you look at this one, C6H12O6. Well, when we were doing ionic compounds, we wanted to make sure we had the smallest whole numbers. That's the empirical. So if I reduce this, each of them by 6, I'd have CH2O, right? CH2O. That'd be reducing all of them by 6. Okay. This is its molecular formula. This is glucose. This is a simple sugar. That is its formula. But its empirical formula, its simplest formula, is the whole number ratios. Okay. So like I said, it'd be CH2O. Okay. This is not the formula for glucose. This is. But this is its empirical formula. There can be many, 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 many derivatives of this. We can have like C2H4O2. We can have C12H24O12. I mean, there's all kinds of, especially when you're talking about carbon compounds. Carbon combines to form all kinds of stuff, okay? So empirical formula is the whole number ratio. And if you're talking about an ionic compound, like a metal and a non-metal, it will always be this number. But if you're talking about molecular compound, we can use multiples. So this is the molecular formula. This is the empirical formula. And again, empirical, or they call it simplest formula, is the smallest whole number ratios. In this case, I would divide them all by 6 and get this. Okay, so note that the molecular formula is a multiple. Okay, I can put in parentheses and put 6 and I'd get C6H12O6. Or you can just, write it like this. Either or, it doesn't matter. But again, empirical formula is the simplest formula. Molecular formula is the actual formula. And I'm going to show you how to find empirical formulas, and then I'll show you how to find the molecular formula once you got the empirical formula. We're not going to do that today because we won't have a ton of time. We're going to not do a ton today, or in this lecture will be shorter, and then we'll finish it off in one more part. Okay? Okay, empirical versus molecular. Again, here's CH. That's an empirical formula. That's the simplest formula. If you look, the percent of carbon and hydrogen are the same. But the masses, because here's acetylene. Those of you that well know what acetylene is, it's C2H2. It is, this is the molecular formula. I'm just doubling everything. Its mass is more, but its hydrogen and carbon are still the same. And here's benzene. Benzene is an organic compound that's used in a lot of processes. C6H6. Look at, it's just a multiple. Percentages are the same, but its mass is different. Okay, it's 6 times this. That's why there's 6's there. This is 2 times this. That's why there's 2 there. So when you're looking at, especially with carbon and hydrogen, you can have so many different molecular formulas for every empirical or every simplest formula. Okay, the ratios of carbon and hydrogen stay the same, but the subscripts, like I said, here you doubled it. Here it was 6 times as much, and so that's why we have 6's here. And again, I'll show you how to figure that out. Okay, empirical formula for P4O10. Okay, they're not the smallest numbers, right? So we can reduce them each by 2. So we'd have 2 to 5, right? Reduce this by 2, reduce this. Whatever you do this one, you got to do that one. So I'd say P2O5 would be our empirical formula. Okay, does everybody see how I got that, I hope? Again, we want this, when we're talking about empirical formula, or another name for it is simplest formula, we're looking for the smallest subscript, the smallest multiples of it. And again, these can both be divided by 2. It's kind of like when you were doing fractions and you always had to have the lowest numbers. Kind of that way. And I think that might be it. Yeah. So we're going to quit here. And then when we pick up next, we're going to start, I'm going to show you how to calculate empirical formulas. Empirical formulas, what's going to happen is you're going to get a percent. And the way this is done is like a lot of the machines, the fancy machines, they have like mass spectrometers and infrared spectrometers. They can run a substance through and then it can identify it by its percentages. They do this a lot like in crime labs. If they get a powder and they don't know what it is, they can run it through a machine and the machine will say, okay, it's this percent carbon, this percent nitrogen, and so on. And you can actually figure out what it is. Usually the machine does it for you. But you can do it yourself. It's not that hard. And I'm going to show you, and that's what we're going to do next. But we'll quit on this for today, or for this part of the lecture, and then we'll pick up on empirical formulas next time. And that'll be the end of chapter 7.